Okay, okay, this is unit number. Okay, this is unit 6, and the name of the lesson is the unit circle. So I'll walk through some of those tasks. The first one is just before that, we better know what are we going to do is in this lesson. Let's learn about the unit circle. I understand that a radian angle measurement is the ratio of the arc length to the radius of the circle. I understand the points on the unit circle can be defined by their coordinates or by an angle of rotation. So let's go directly and do some of the tasks. So the first one is, okay, okay. So you see this is given to you. Mm, what you are supposed to do is the x coordinate of a point on the unit circle. So this is a circle, which is a unit circle. So it only means from here this is 1. So that's what that means. No matter where, this is 1, this is 1, this is 1, okay, like that. Then the next question is asked is, what does this tell you about about where the points might lie on the unit circle? So the x coordinate of a point is given. So this is 3/5 is the x coordinate. Now what does this 3/5 basically mean? So this whole thing is, so let's put this is 1, right? So if that is 1, each of the spaces is 1, 2, 3, 4, 5, 6, 7. Each one of them will be like a 0.1, 0.2, 0.3, 0.4, 0.5, and like that. So 3/5 basically means it will be 0.6. So where is zero point 0.6 is, we mark 1, 2, 3, 4, 5, and 6. So the x coordinate here, this is the 3/5. Sorry, this one. This is 3/5, right? So, so we want to know which coordinates, where are those points where it will have 3/5. So I can go directly and say, okay, we can think of going from here all the way here. Look at this. So that point, so either you can think of this point, which is in the first quadrant, or you can go on the other side in the fourth, fourth quadrant. So either first quadrant or fourth quadrant. So we can write, so let me clone this. We get two more. So I'll put it here and then I'll take it. So one is up here. So this coordinate will be here. This will be, so this will be 3/5. Okay, that is 3/5. So this point also is 3/5. And the y coordinate, the first quadrant, you see the y coordinate, I can go all the way here, and that's 0.08, because 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. And zero point 0.8 is 8/10, and this is 4/5. So this becomes plus 4/5, and the other side will be minus 4/5. That's all it is. So for each point 3/5, you can have the y coordinate one positive 4/5 and negative 4/5. So let's see, the next part is, one more question is, so let me take this off, and the next question is asked, this time they give you the y coordinate of a unit circle is minus 0.4. So where is minus 0.4? So let me take uh, minus 0.4 will be 1. So 1, 2, 3, and 4. That's the point. So this point, this is 0 minus 0.4. So Or we can say, hey, this point is 0 minus 0.4. Now what is minus 0.4 means? It is 2/5, 4 divided by 10, which is 2/5. Yeah. So at that point, we'll have to draw two more. Uh, so here you can either go this side and you can go on the other side also. So those are the points that will have x coordinates. So this point here will be the y coordinate here is 0.4, and here also this point will have y coordinate minus 0.4. But how do I find the x coordinate? So what is this? So what goes right here? So what goes right here? And remember, you can use this is 90 from, so this is one, and we can figure out using the Pythagorean theorem. This is 1, and then this part is 0.4, 0.4 here, and we can find this distance by using Pythagorean formula. So it's like a square plus b square equals c square. So you can write 0. A is what we don't know, plus 0.4 and 1 square. If you get a square, this will be 0.16 equals 1. And if you take away this on both sides, so you get a square is 0.84. And if you take a square root, so you get two answers for this. And those answers are, I did calculations, I get 0.917. So you get plus minus 0.917. That means this is on the left side, that is in the third, this is the third quadrant. So the third quadrant is minus 0.917, and here it is plus 0.917. That's it. So for y coordinates, you have two x coordinate. Then the third quadrant is going to be minus, and the fourth quadrant will be plus. Okay. Hope that helps. So let's go to the next one. Now this is the 3.2. What they gave us is each of this point. Let's see this. I will take a point like this. Let's take one. I'll begin from the center of the circle, and this is the radius 1. Okay, and I'm gonna clone this because I want to rotate this. And let me clone this and change the color to red. Okay. Okay, so that means now I'll take this back. So it is this. These are like two rays. Let me start here. This one. So this is, I can rotate this either in the counterclockwise direction, or I can rotate it in the clockwise direction. So this time, let's see. They're asking us choose one of the points. Be prepared to disguise location using only words. So what are you supposed to do is, I'm going to rotate this, and let me I'm going to rotate this point right here, see? And when I rotate this point, there's an angle getting formed. So the rotating around this point, and that is the angle in the counterclockwise direction. When you go, you see there's an arc. So this is the arc. So it goes along the circle. This is along the circle. So the arc, and then the angle is formed. So that point is right below. There will be another point. So let me see if I can clone one more. So let me take this point. So this point, you can take the other side. They are reflection over the over the x-axis. So this is the x-axis. So whatever this point will be, let's see, if I don't know what is this point here. Let's see if this is x1, so this point will have x1, and this also will be same x1, and the x1 will be same, but the y will be different. Here it will be y1, and this will be minus y1. So that's all you're supposed to write. Choose one of the points and be prepared to describe its location. So this location is the first quadrant, and this point is in the fourth quadrant. Or you can also select another one. Instead of this, you can say, okay, I can go this side. So that's like reflection over the over the y-axis. So this is the y-axis. So that means if this is x1, y1, this point will be minus x1 and y1. So kind of to understand that, so whenever this point is reflection, they have the same x coordinate, but the inputs which are x1 here, and this side it is minus x1. So this is x1, this is minus x1. So I hope that takes care of this. So let me see what I'm trying to say is, if this is the unit circle, they gave us it's a unit circle, already told us this is 1, so this is 1. That means this point, suppose I drop 1 here, okay, if I drop a 90 degrees, so this will be maybe 0.6, let's say, and this one will be maybe 0.8. So that point becomes like a 6 pi. Zero point 0.6 means, so 0.6 is 6 over 10, which is 3/5. We can check, and this will be 4/5. But this side, this point will be minus 3/5 and 4/5. But if I take on the other side here down, this will be 3/5 but minus 4/5 because it's in the fourth quadrant. And this side, if I go here, this will be minus 3/5 and minus 4/5. So I hope that makes sense. Now let's go to the next. So this is 3.3 measuring circles. Your teacher will give you a circular object. About how many radii does it take to go halfway around the circle? So what I'm going to do is draw a circle here. So let's draw a circle. So let me draw the circle. Okay. You can change this color to maybe blue color. No, the line. I want only the line. So I want the line blue color. Okay. So this is a circle, and let's consider the circle is of radius 1. So I'm going to pick this part, and the radius is, let's see, this is 1 here. This is 1, okay. So the question is asked, about how many radii does it take to go halfway around the circle? Now, all around the circle basically means circumference, right? So because, what is circumference? It's the length of the, so it is the length of the circle, which is 2 pi r. And in this case, let's see, if I take 1 here, this becomes 2 pi times 1, which is 2 pi. Now, this is 2 pi is all around here. Now, this is 2 pi. So if I want to go only halfway down, so this way, so you go around, this is the, so how many of them should halfway? So halfway will be just circumference is pi. So because all around is this, so this is pi, which is 3.14. How many radii does it take to go all around? And that is, we saw it is 2 pi. Compare your answer to the previous two questions which with you. So we wanted to know the previous question. So it takes 3.14 for halfway down. And what is this 2 pi is 2 times 3.14, which is 6.28. So what that means is, because this is 1, so how this basically means, so let me take this off. What that basically means is how many radii can we fit there. So this is whatever this one here, this is one, right? So it means you can go, this could be somewhere here will be one, because the same length I'm trying to find the length of the arc. So this will be maybe 1 radian. The one radius fits here. Then you can put another same somewhere here, and so on. And you can put another one, and this will go slightly before. The reason is because until here is, remember, it was 3.14. So till here will be somewhere like another one more radii. So here there are three, one, one, and one. And then again, you can see the other black color. Let me use that. This is another arc here, maybe here till here. Then you can have another red one, like this, till here. And then another green one till here. And you'll still see there. So these are 6 of them. 1, 1, 1, altogether 6. See? So I can say 1, 2, 3, 4, 5, and 6. And still there are small pieces left there. So let me use that color difference. This is that small piece which is left. And what is that is, because it was 6.28 is the whole semicircle, circumference, plus 0.28. So this part is 0.28. So we say, okay, how many radians fit in the whole circle is, we say, okay, that's 1 radians, because this as angle. So an angle is created by this black color creates, this black arc creates 1 radian. There's an angle at the center. Then again, there's another angle, 1 radian. Then this becomes another radian. Okay, and then you have another radian here. Then there is another radian here. There is another radian here. So there are 6 radians, and then so we say all around the whole round is 6.28 radians. It means there are six. There are six radius. Six full radius. Six full radius fit the circumference, and also 0.28. That means almost like 1/3 of radius. So like 1/3 of radius also fits. So we say, okay, all around is, we say the whole round is actually 360 degrees. And you will see this 360 degrees, this 360 degrees, when you go all around, you're using 6.28 radii. So this is radii. So 360 degrees, we are going to use something called 6.2 radians. It means 6 radians, full radii, and 0.28 fit the whole circumference. So we kind of move to another way of measuring angles in radians. So we say, okay, how many radians fit the whole round here? Okay, what if this circle, now I make it a little bigger, okay? Just wanted to see if I make this circle bigger, let me see. I'm making it like a bigger circle. And then this time, let's see, this is 3, radius is 3. Let's see, this is 3. And then circumference for this will be, so this circumference will be 2 pi into r, which is 2 pi and into 3. So this is 3. Let's see, radius is 3. So that is 3 to the 6 pi, which is 6 times 3.14. If you multiply 6 times 4 is 24. 2, 6, 1, 6, 7, 8, 6, 3 are 18. So that means we can fit here, if this is 3, then we can fit here 3, then we can fit another 3, then you can fit another 3, and the same thing you do 3, see 3, then you do another 3, and then you another 3, see this part. So 3, 3. So 3 plus 3, 6, 9, and another 3, 9, 18. So this part, what do you see is point. So this will be 0.84, which is basically nothing but 3 times 0.28. Okay, I could have drawn another circle, unit circle on this one. This could be 1, and I can draw another one with 2. See, so this is like 2. So what I'm trying to say is that this part, so if I try to draw like this, let's imagine I have why I'm showing this point. Look, watch this fun. So the arc here is this arc. This is that 0.28, because if I have a 1 unit here, so this will be like 1, 1, 2, and then 3. Then you have again 1, 2, and 3. So there are 6, and then little piece here is that 0.2. And because this is the 3, this is the radius 3, so you multiply, when you multiply, you get 0.86. And that's where you have, so 0.84. So this is that 0.84 here, right here, which I was saying that it is 18 and 0.84. So there is a scale factor of 3 here. So this is 3. So in the beginning it is 0.28, and then this is 0. Uh, uh, if you multiply this by 2, you get 2 8 is 16, 6 1 carry, 2 to the 4 5. So that's 0.56, this one. So this is 0.56. This one is 0.84. Hope that helps. So in other words, it does not matter. It is proportional. So whatever this, it is proportional to whatever the arc length there. Okay, around a bike wheel. What this says is a bicycle wheel has a 1 foot radius. So there it is. This is 1 foot. This is 1 foot. Okay, this is the wheel of a bicycle. The wheel rolls to the left. Means it goes like this. It goes to the left this way. What is the circumference of the wheel? So what is the circumference? The first question is circumference is 2 pi and r. So that is 2 pi times 1, which is, and we have seen this, this is 2 times 3.14 is 6.28, and you're done. So all around. Now it's a mark point Q where P will be after the wheel has rolled 1 foot to the left. That means if whatever this is, I have to rotate it maybe somewhere here. We don't know exactly. That length, 1 foot, may be this point here like this. So that's, and when this is rotated 1 foot to the left, that means there is an angle getting formed. What this is, the angle is getting formed here, and that angle is called 1 radian. Why? Because you can fit 1 radius here, the red one. So basically, the red, if this is the red and the green, they are the same. Okay? So this green is right here, but the red one is curved like this. So that's where the point is P. So, okay, sorry, Q. This is Q. Mark Q where P will be after 1 foot to the left. Be prepared to explain the reasoning. So the reasoning is you are trying to cover the around the arc here, right? That's why. So it will be somewhere here. Mark the R will be after the wheel has rolled 3 feet to the left. So it means, oh, I already showed this to you earlier. So that means another part will be somewhere, maybe somewhere here, and then another one will be somewhere here. So this is not perfect, but as I say in the previous example I showed, so there are three radii, 1, 2, and 3. So so these are like one radius, one. So 1, 1, 1 is put there, and that's like 3 radii. That's all it is asking you is mark R. So that's the R here after the wheel 3 feet to the left. What angle in radian does P rotate through? So in order to get from here to here, what angle, how much angles means what, how many radii fit? So there are 1, then 2, and there are 3. So this is how you say, okay, 3 radians. Why? Because to rotate and come to R, so you fit in 3 radii. So you have 1, that's one of the radius, then the black one, and then again the red one. So there's another question number 4, which says, the question number 4, where will be the point P? So where will this point be? Has traveled pi feet to the left. Now, what is pi basically means? Remember circumference. The circumference was 2 pi, right? So this point goes all around somewhere here till here. So this is pi. So the point will be right here. That will be the point. Since pi is half of the circumference of the wheel, after rolling to the left, pi feet to the point P will be at the point, this we can mark a T maybe here. So that's the point T, directly opposite to the point P on the circle. And since 2 pi feet are full circle, so this whole thing is like 2 pi, 2 pi. So since each 2 pi feet are one full revolution of the wheels, the whole round is one full revolution of the wheel, and this will be this will the whole one. This will be 2 pi. So after 2 pi, this will be again 4 pi, 6 pi, 8 pi, 10 pi. So if it is 10 pi, you go back to the original point P. I hope that takes care, or I can show with the help of this way. So this is this one. So you can see this part is here and it goes pi, 2 pi. So that's whole revolution. 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi. So if it is 10 pi, you can write 10 pi is 5. So 5 full rotation, 2 pi. So 2 pi is one revolution. One revolution. And 5 times. So you'll have to go around 5 times to get back to the same place. So I hope, yes. So where will be the point if it is says, let's say if it is says 3/4, 3/4 revolution. Now where is 3/4 revolution will be? This will be, let me clone this. So this point will go, this is like, so if this is pi, this will be like a quarter of this. This is semi of the circle, and this will be 3 pi by 2. Means This will be pi, that's pi, and then again this is like a pi by quarter of this. So you get, so this is pi by 2 because a half. So it is total becomes pi plus pi by 2 is 3 pi by 2. So this all around this angle will be measures, we say 3 pi by 2. So that is question number 5. They're asking that's the lowest location. So this pi. So when will be the lowest location of the point will be? It is after 3 pi by 2 radians. Because this is pi and this is half of it pi by 2, right? So hope that makes sense. This is pi by 2. So this top is pi. So the lowest will be pi plus pi by 2. I hope this helps just to understand that what is going on in this is basically we are saying, okay, instead of the whole round will be like instead of whole round is 360 degrees. So henceforth this 360 degrees will be written now in radians because it completes 2 pi. So this is 2 pi radians, we say 2 pi radians. Or we say, okay, pi halfway down will be 180 degrees. So instead of 180 degrees, we'll say, okay, pi radians. Pi radians means 3.14. That means you're going to still fit 3 radii, full radii, and plus 0.28 to complete the whole pi. So pi will be this one. So if I am confusing you, let me complete this and finish this off. So the goal is just to understand this part. This part. So this is the circle. So whatever the radii, let's say this was the radii. So you kind of put one here like this. So that's what I'm trying to say. And then you put another one, and then you put another one, and you go just below because this will be pi, which is 3.14. Because that's semicircle, half the circumference you have. So whatever the radius here r, you put r here, and r here, but still there will be small piece remaining here. This piece is what I'm talking 0.28. And you do the same thing on the other side. This is I'm repeating the same thing. Let's say this is still here maybe r, and then you have another radius you can fit in here. This is one more radii, and then you put another black one. So there is another 2.8. See, this is another 2.8 here, 0.28, and which is goes to, sorry, 2.14. This is 14. I made a mistake. 14. This is 14. So 0.14 and 0.14 becomes 0.28. So this piece, which is this is that additional. So you have 6 full radii and a small 1/3 of it. Okay, so this completes that. Done. And hope that you understand this. I just thought of explaining is another way to measure degrees is radians to check how many radii fit. That's all it is. Thank you and complete the work.